We've pretty much finished the fireworks mechanics and shader with the last video. For this video, I will be making small adjustments and will explain the additional concepts for this fireworks geometry node. Okay, please take a look at this to spot an issue. Can you tell that there is an extra space between the center of burst and where the tail begins? This is caused due to a calculation order during spawning, so let's fix that. First, create a space between this delete geometry and simulation zone. Then, move this join geometry over to the spot, reconnect the lines, and reroute. Pretty simple remedy. Just to confirm, rerun the animation and we can observe the space is gone. Next, let's add some control over launch timing. Currently, our geometry node will always launch the shell at the first frame. Let's make it so we can control that. First, open up the side panel and add an argument. Keep the type as float and call it launch timing. Plug it in to spawn timing for the first init shell. This is not enough since simulation zone will keep on updating. We also need to change the skip condition. First, add a scene time. Pull out a less than and compare it to the launch timing. Plug the result into simulation zone skip. Now, simulation zone will halt its calculation until launch timing is reached. Alright, let's input 1 second from the modifier tab and rerun the animation. We can see that launch timing is delayed to 24th frame. It's also a waste to keep a geometry awaiting launch in the scene, so let's delete that as well. Add a delete geometry here and connect the previous conditional to selection. This prevents unnecessary mesh from forming. Next, let's add a little more control to launch. Let's control its direction. Currently, we can control launch direction with this init velocity. Let's break this up to direction and magnitude, then turn them into external input. First, open up the side panel. Add an argument, set type to vector. Call it launch direction. Add another argument, keep it as float. Call it launch speed. Add a group input into the map. Normalize the launch direction and turn it into unit vector, then scale it by launch speed. Plug this in to initial velocity of init shell. Input 1 into direction Z and appropriate value to speed if you want to launch vertically. If you want it to tilt, input some values into X and Y. We are done with today's node update. We change the processing order by moving join geometry. and we also added a few controls over launching. So, let me talk a little about future videos. Currently, all the mechanics is done, and it is possible also to render. I was only planning to go this far for the tutorial. However, it feels kinda half-assed leaving you with just this one simple firework. I mean, we've basically gone through making things like physics engine just for this one bang. Last thing I want is for you to leave with some sense of wasted time. So, my plan is to turn this geometry node into a more useful generator. In order to do so, I have to introduce you to concepts closer to programming and not computer graphics. If you do not feel comfortable pursuing such topic, I won't force you to continue. However, by following the tutorial, you will be able to create firework variations like these with ease. It might be uncharted water for some, but will likely help you in the future. So please consider carefully. Okay, so just to explain, here's an illustrated representation of our node tree. We've combined things like physics, shell design, launcher, shader. All these basically affect each other and result in a firework system, just like real life. Now, it would be a waste of time to recreate all of these, just because we want to see differently shaped firework. So programmers use concepts like object-oriented programming and classes to avoid such waste. We separate out parts that change as independent object or class, and make it possible to design variations without affecting the original object. For this node tree, the object we want to separate out is a shell design. Just like in real life, we want to achieve different result with shell A and shell B if the design is different, even if we were to use the same launcher. Alright, I've explained enough. From the next video, I'm going to be focusing on how to achieve such system with Blender geometry nodes. Since current geometry node is not a formal object-oriented programming language, it might not be the most stylish implementation, but it is the best implementation I was able to come up with. So thank you for watching and see you next time.